Now we'll take a look at an example where we have to find all the possible zeros and factor the polynomial function. Now, in this example, we have not, or in this sample problem, we have not been given any idea of what to start, what's a good starting place. So we have to actually come up with our list of possible rational zeros to start. So we'll start, so I'll just do it in parts. So we'll start with our p-values. Our p-values will be all of the factors of 21. So we got to remember our plus and our minus factors. So we have 1, we can have 3 and 7, and then of course the 1 and 21. So we could have positives and negatives of all those. Then we have to do q, and q is plus or is 6, so we have to do all of the possibilities of the leading coefficient is 6. So that's 1 plus or minus 2 plus or minus 3 and plus or minus 6. Now that we've found the possible factors of p and q individually, we need to find all the possible rational zeros, and so these are going to be the combination of the p and the q, and so we're going to find all the combinations of the p over the q. Now plus or minus 1 was given both times. We only need to write it once. And so what we're going to start off with is every single one of our p-values over 1. So that should be pretty straightforward here. It's just a repeat of all the p-values. So those are all the possibilities over 1. But then we have to go through this process again and put all of those possibilities over 2 as well. And so we'll go ahead and do that also. So 1 over 2, and so I did all of the possibilities over 2 as well. Now we need to do all of the possible p's over 3. Now if you notice, if we do plus or minus 3 over 3, that just gives us a 1, so we're back to where we were before. We've already had that, so we do the 7 over 3. Also, if we do 21 over 3, that gives us plus or minus 7 also. So that's another one that we don't need to repeat or write all over again. And then lastly, we need to write all the possibilities of p over q, and so we now need to work with the 6. And 3 over 6 is 1/2, so we already have 1/2. So we'll skip that one. And then 21 over 6 reduces to 7/2 as well, so we don't need that one again. So now we have all of our possible rational zeros. Now, even though this looks like a very large list, which it is a pretty big list of possible rational zeros, it's a heck of a lot smaller than picking just random numbers out of an infinite number of possibilities. So again, what we're going to do is we're going to start, and this is where you have to kind of play with this a little bit. I would start with some of your easier numbers, your 1, your 3, your 7, before you get into your 1/2 and your 3/2 and things like this. Now, what I would recommend, and this is an effective way that you can use your calculator, is graph this polynomial function on your calculator. See where it crosses the x-axis, and that'll give you a good starting place. And if you do that, what you'll notice is this actually crosses the x-axis at -3. By graphing this on your graphing calculator, you can see the 3 zeros take place, and you can see that 2 of them look like they're halfway between, and you could see that that looks like but 1 is directly on an integer value, which is -3. So what we can do is we can use that -3 value immediately to go straight into our synthetic division, and hopefully that'll help us find the factors much quicker. So I've set up the synthetic division. I'm going to go ahead and work this out now, and as we had hoped, we ended up with a remainder of 0, and we kind of knew that was coming because we had a good eyeball on that. So you can see that we can use the calculator to get a visual. So make sure you use that very, very well. Now, if we look at our depressed polynomial, we're going to have x squared and x. And so now it's going to be our job to factor that final piece. And of course, we're going to end up doing that with grouping. And so you would want to do the grouping process. And so part C would actually tell us to do the whole thing. So f of x. And keep in mind, this minus 3 is c. So if c is minus 3, that's x minus a negative 3, which means our factor is x plus 3. And the 6x squared minus 19x minus 7 is actually going to factor into 3x plus 1 times 2x minus 7. And so that would be the final factored form of this polynomial function. So you can see how we can come up with a list of zeros. We can use our calculator to give us a visual aid of the possible zero. If you don't use the calculator, it may take a few synthetic divisions to prove or disprove a zero in this case, and so it may take a little bit longer. So I definitely recommend using your calculator right now while you're learning how to do this process. And of course, this process is gonna spill over into solving polynomial equations in the near future.